Alright, hello everyone. I'm going to go over some problems that you may run into in problem set number 5. First one, it says, find the center and radius of a circle with this following equation. Well, if you take this equation and you put it into the standard form of a circle, let's see here, like this, then you know the center are the letters H and K. Whoops. Here's the letter K instead of Y. And we have center here, and we have radius r. Alright, so let's just take it and we're going to move this equation into this form. Well, it's going to require us to complete the square, so I'm going to write it like this: x squared plus 4x plus something to complete the square, and then the y squared part is here, and let's put the 89 over here, and I like to write these numbers right there. So let's see, to figure out this number here, we take b divided by 2 squared. So 4 divided by 2 is 2, squared is 4. Whoops, that's an 8, my fault. 8 divided by 2 is 4, 4 squared is 16, and another 16, and we're going to add those over to both sides. So if we add it to the left, we add it to the right. I added a 16 here, there, another one, and another one. Alright, so this is a perfect square. And so is this now. And 89 plus 16 and 16 is 121. So we can pick apart all the pieces we need. The center of this equation is now a -4 and a -4. And the radius, if you look at the equation, takes r squared. 11 squared is 121. So there you go. So if you were to graph this circle, you could go to -4, -4. And make something with the radius 11, somewhere large circle out in there. Alright, you're also going to run into some trig problems, and last week we talked about what radians are, so hopefully you know that this is the same as the sine of 45 degrees. So now you can plug that value into your calculator and you would get an answer, but I'm going to show you how to do it with using this unit circle over here. So if I say sine of 45 degrees, well, what I mean is I'm going to draw this 45-degree angle with radius 1 in this case. And then what I'm going to do is I'm going to use my sine, so toa, and sine means opposite over hypotenuse. So I need this side here, this opposite side, over this side. Well, if you look at this unit circle, the coordinates of this point are root 2 over 2, root 2 over 2, meaning I go that direction, root 2 over 2, and that direction, root 2 over 2. And the sine value is this opposite over this hypotenuse, so it's root 2 over 2 over 1, which is simply root 2 over 2. So the sine of pi over 4 is root 2 over 2. And if I check that with a calculator, if I hit mode, let's go ahead and put it in, I'll just put it in degrees to make it easier. Sine of 45 is 0.7, and watch what happens. If I go root 2 divided by root 2, there's the same value right there. Alright, one more, same type of problem. Find the reference angle and the quadrant of the terminal side of this 150 degrees. Well, when we're drawing stuff on the unit circle, we start from 100 or from 0 and go this way. So I'm going to put 150 about right there. That is right where about 150 degrees would be. Then I draw this triangle down, and so my reference angle is 30 degrees. There's my reference angle. Alright, what quadrants? Well, the quadrants are 1, 2, 3, 4. So it's quadrant 2. Now I just need to know the sine and the cosine. Well, again, I'm going to make a bigger version of this triangle over here so we can see it better. 30 degrees, and it's this triangle here on this unit circle. If I shade that in, it's that triangle right there. Well, the height is 1/2. The left distance is root 3 over 2. And this distance is 1. And what do I need? Sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse. So what is the opposite? 1/2 over 1. 1/2. What is the adjacent? -√3 over 2. Just be careful that you have a negative there on this cosine, because this distance here, it's negative from the axis that way. All right, hope this helps you get started on your work on week 5. If you have other questions, please email and be happy to go over them with you.